Okay, hi everyone, welcome back to this video series on data centers. The application layer. The application layer of the OSI model marks the spot where users actually communicate to the computer. This layer comes into play when it's apparent that access to the network is going to be needed soon. Take the case of Internet Explorer, i.e. you can uninstall every trace of networking components from your system such as TCP, IP, NIC card and so on, and you can still use IE to view a local HTML doc with no problem. But things would definitely get messy if you try to do something like view a HTML document that must be received using HTTP or a NAB file with an FTP or TFTP. That's because IE will respond to requests such as those by attempting to access the application layer, and what's happening is that the application layer is acting as an interface between the actual application program, which isn't at all a part of the layered structure, and the next layer down by providing ways for the application to send information down through the protocol stack. In other words, IE truly doesn't reside within the application layer. It interfaces with application layer protocols when it needs to deal with remote resources. The application layer is also responsible for identifying and establishing the availability of the intended communication partner and determining whether sufficient resources for the intended communication exist. These tasks are important because computer applications sometimes require more than only desktop resources. Often they'll unite communicating components from more than one network application. Prime examples are file transfers and email, as well as enabling remote access, network management activities, client-server processes, and information location. Many network applications provide services for communication over enterprise networks, but for present and future internetworking, the need is fast developing to reach beyond the limits of current physical networking. The presentation layer. The presentation layer gets its name from its purpose. It presents data to the application layer and is responsible for data translation and code formatting. This layer is essentially a translator and provides coding and conversation and conversion functions. A successful data transfer technique is to adapt the data into a standard format before transmission. Computers are configured to receive this generally formatted data and then convert the data back into its native format for actual reading, for example EBCDIC to ASCII, by providing translation services. The presentation layer ensures that data transferred from the application layer of one system can be read by the application layer of another one. The OSI has protocol standards that define how standard data should be formatted. Tasks like data compression, decompression, encryption, and decryption are associated with this layer. Some presentation layer standards are involved in multimedia operations too. The session layer is responsible for setting up, managing, and then tearing down sessions between presentation layer entities. This layer also provides dialogue between devices or nodes. It coordinates communication between systems and serves to organize their communication by offering three different modes: simplex, half duplex, and full duplex. To sum up, the session layer basically keeps different applications data separate from other applications data. The transport layer. The transport layer segments and reassembles data into a data stream. Services located in the transport layer segment and reassemble data from upper layer applications and unite it into the same data stream. They provide end-to-end data transport services and can establish a logical connection between the sending host and destination host on an internetwork. Some of you are probably familiar with TCP and UDP already. You know that both work at the transport layer and that TCP is a reliable service and UDP is not. This means that application developers have more options because they have a choice between the two protocols when working with TCP/IP protocols. The transport layer is responsible for providing mechanisms for multiplexing upper layer applications, establishing sessions and tearing down virtual circuits. It also hides details of any network dependent information from the higher layers by providing transparent data transfer. The transport layer can be connectionless or connection orientated. However, Cisco is mostly concerned with you understanding the connection orientated portion of the transport layer. The following sections will provide the skinny of the connection orientated reliable protocol of the transport layer. Flow control. Data integrity is ensured at the data transport layer by maintaining flow control and by allowing applications to request reliable data transport between systems. Flow control prevents a sending host on one side of the connection from overflowing the buffers in the receiving host, an event that can result in lost data. Reliable data transport employs a connection-oriented communications session between systems, and the protocols involved ensure that the following will be achieved. The segments delivered are acknowledged back to the sender upon their reception. Any segments are not acknowledged are retransmitted. Segments are sequenced back into their proper order upon arrival at their destination. A manageable data flow is maintained in order to avoid congestion, overloading and data loss. Connection-oriented communication. In reliable transport operation, a device that wants to transmit sets up a connection-oriented communication session with a remote device by creating a session. The transmitting device first establishes a connection-oriented session with its peer system, which is called a call setup or a three-way handshake. Data is transferred. When the transfer is finished, a call termination takes place to tear down the virtual circuit. Figure 2.8 depicts a typical reliable session taking place between the sending and receiving systems. Looking at it, you can see that both host applications programs begin by notifying their individual operating systems that a connection is about to be initiated. The two operating systems communicate by sending messages over the network, confirming that the transfer is approved and that both sides are ready for it to take place. After all of this is required, synchronization takes place, a connection is fully established and the data transfer begins. The virtual circuit setup is called overhead. While the information is being transferred between hosts, the two machines periodically check in with each other, communicating through their protocol software, ensure that all is going well and the data is being received properly. Here's a summary of the steps in the connection orientated session. The three-way handshake picture figured in 2.9. The first connection agreement segment is a request for synchronization. The next segments acknowledge the request and establish connection parameters, the rules between hosts. These segments request that the receiver's sequencing is synchronized here as well, so that bidirectional connection is formed. The final segment is an acknowledgement. It notifies that the destination host that the connection agreement has been accepted and that the actual connection that has been established, data transfer, can now begin. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.